Well, dear friends, now come to the main topic, diffraction of light. In last video, I explained you the meaning of diffraction as well as condition of diffraction. And I told you that diffraction is the common property of the waves. Whatsoever is the wave, electromagnetic or mechanical wave, when a wave crosses an obstacle in the path or it passes through narrow or any hole, it bends around the corner. This is a property of wave. Now, I told you that in case of sound, diffraction commonly observed because the condition is that the size of hole or slit should be size of wavelength. Light wavelength is of the order of a certain meter, while wavelength of light is certain thousand angstrom. So, in light, diffraction is not commonly observed. You can observe here, if you want to understand. First of all, I tell you what is this. In figure 1, here is a narrow slit S. A monochrome light is incident in the form of plane wavefront on slit S. In figure 1, monochrome light is incident normally in the form of plane wavefront WW. Now, according to ray optics, this is the width, then light should be only in this part only. But after passing through the slit, light goes beyond the limit of ray optics. And it goes beyond the limit of ray optics, means it enters the shadow in one sense. This phenomenon is diffraction of wave, and this theta is called angular spread. So when light passes through narrow slit, it bends around the corner of the slit as shown in figure 1. Here it is monochrome light falling on slit S. The intensity does not become zero exactly in the ray optics, but goes beyond the limit of ray optics. This phenomenon is diffraction. To explain this bending, we have taken figure 2. The figure 2 represents magnified view, enlarged view, magnified view, enlarged view of the slit. The slit is same, but suppose we have, just like when you see the slide under microscope, the things which are not visible to you becomes visible and become dissolved. So L and N are the two ends of the same slit. The width of slit I have taken A. Now we have divided here slit into two halves, LM and MN, and further there are M1 and M2 are the two midpoints in the two halves. M1 is the midpoint of half Ln, M2 is the midpoint of half Mn. Now when plane wavefront WW dash, WW is incident normally. Wavefront, I have told you what is the meaning of wavefront? Locus of points oscillating in same phase. So because all the, according to Huygens theory, all points of medium on wavefront are oscillating same phase. So when it strikes the slit, every particle of medium in narrow slit S start oscillating with the frequency of light falling on them and start sending secondary wavelets. Please make note of all this lecture because I will write here, take long time, but I am telling you again and again Ln is the enlarged view of slit L. M is the midpoint of slit width A. M1 and M2 are further two midpoints of two halves. WW is the wavefront of monochrome light, plane wavefront of monochrome light. It is incident normally. When the slit is struck by this wavefront, every particle of medium inside the slit start oscillating with the frequency of light of wavefront in same phase, because wavefront is the locus of point oscillating in same phase. These oscillating particles of medium inside slit become secondary source of wave and produce secondary wavelets which start traveling toward the screen. Point O is exactly equidistant from two halves. Point O exactly equidistant from two halves of the slit. So the secondary wavelets starting from point L and point N meet with part difference 0, and since they are in same phase, so meet in same phase at O. So like L and N, every point M1 in first half meet with other point M2 in second half. Means for every point M1 there exists a point M2 in second half which meet at O in same phase. Please make note of this, because if I will start writing it will take long time and we are bound to save time in this video. But as we move away from O to P, then they start occurring part difference. And due to part difference, delta phi equal to 2 pi upon lambda into delta x. If there occur part difference, phase difference of secondary wavelet will start occurring and they will start getting out of phase. Phase difference between the secondary wavelet from first half and second half will start changing, and hence intensity of light start decreasing as we move from O to P. Suppose P is the point where we get minimum zero intensity. Then suppose the point PL or PN will be distance PN and PL will be different. So we have got PQ equal to PL. Actually here, please, the rays here are shown parallel. I have told you normal to the wavefront are called rays. So these are rays. Please listen me carefully. Wave always travel in straight line. The wave character is something different. That wave, I have told you many times, what is wave? The variation in some physical quantity which transfer energy. So these are the wave rays. So we have got PQ equal to PL from PN, and here NQ represent part difference between the wavelets starting from point L and N. If point P, I have told you, is the point where we get minimum intensity, is such that the path difference NQ equal to lambda, then path difference between secondary wavelets starting from point L and M is equal to lambda by 2. This theorem of geometry, in a triangle line drawn through the midpoint of one side parallel to the third side, other side is half of the side, and if it is lambda, so this will be lambda by 2. And according to the equation, the phase difference between secondary wavelet from point L and M, hence phase difference between secondary wavelets starting from L and M, delta phi equal to 2 pi upon lambda into lambda by 2 is pi. Hence secondary wavelets which are called secondary waves, meet from point L and M, meet at P in opposite phase. And hence cancel each other and produce zero intensity. I agree that this topic is totally abstract in nature. The whole wave optics creates lot of trouble to students, but I am explaining you in the way I have got it from my own brain, and every student who I teach this topic appreciate me. Sir, you are doing well. I don't know why do they so really they understand or not, but I hope they understand me here. So you will also understand me here. What I told you, when plane wave front W strikes the slit, every particle of medium start oscillating in same phase because wave front is the point, the locus of point oscillating in same phase. At point O, secondary wavelets from every point L and N, M1 and M2 meet in same phase because point O is equidistant from two halves of the slit. But if we go from O to P, there is a part difference delta X. If point P is such that the part difference NQ between secondary wavelets starting from L and N is lambda, then part difference between secondary wavelet from L and M will be lambda by 2, and hence they meet in opposite phase P and produce zero intensity. Now we can say here 4, and hence for every point M1, every point M1 in first half in first half there exists a point M2 in second half of slit, which cancelled each other, and hence intensity of light, hence intensity of light is 0 at point P. So light is spread not only this way also. And the condition for minimum intensity, the general condition for intensity to be 0 at different points on screen is here it is A, width A, this is theta, this is perpendicular. So A sin theta is equal to plus minus n lambda. Minus lambda means this side also. But for n equal to 1, we get point P, first point P, where intensity 0. And hence for point P we can write A sin theta is equal to lambda, or sin theta is equal to lambda by A. I have told you many times theta is very small. Generally theta comes small. So if theta is small, very small, and dear listen me carefully, this approximation is valid up to 10 to 15 degree. Then sin theta is equal to theta is equal to, so theta equal to lambda by A. If lambda is equal to 6,000 angstrom, you can say 6 into 10 to the power minus 7 meter, and A is equal to 1 centimeter, 10 to the power minus 2 meter. Then theta comes out to be 6 into 10 to the power minus 5 radian. Remember that I have told you that 1 radian is nearly equal to 57 degree. So this angle comes very small and cannot be, so this angle is too small to be observed. But if A is equal to 0.001 millimeter, then you get 10 to the power minus 6 meter. Then theta with the same wavelength will be 6 10 to the power minus 7 upon 10 to the power minus 6, so 0.6 radian. and this much angle come out to be nearly 30 degree, nearly equal to 30 degree, and this much angle spread cannot be neglected, cannot be neglected. So when size of slit is very small, means it's just nearly close to size of wavelength, then diffraction of light has to be taken care of. There are different troubles, different things which we have taken care. I will be telling you later on. Now theta here I told you lambda by a. Now you can understand here. If I look this light, source of light through my fingers, I feel different colors in this light. The bulb is white source of light, so it has all possible colors in their light, and these lights have different wavelength, so angular spread is different. So when we look through narrow holes, the white source of light from large distance, then we find colors in the light, because angular spread depend on wavelength and size of the slit. By lambda or theta is equal to lambda by a. In white light, these wavelengths vary from 4000 angstrom to 7000 angstrom. If size of slit is of this size, close to it, then you will find colors. If you see the distant bulb in rainy season, because of moisture in air, there are droplets of water. Those droplets of water act as obstacle. So from the light of bulb, any bulb or any source which is produces white light, you observe pattern of colors in the light. The moon, when light comes through clouds, appears to make colored rings around it. That is because of diffraction of light. I hope you might have got me. Now things are remaining. I will take more things in next video about diffraction of light. Please don't go away from the slits, these videos. Watch this thoroughly again and again. This is very important topic, and important means to understand what is light diffraction and what is the use of diffraction of light. I will be telling in next video. Thank you.